All right, 3.2, solve linear systems. Algebraically. So we're going to start out with substitution, and then we're going to see where we're at time-wise when we're done with the substitution problems and go from there. I usually split this up into 2 days just because of how it falls and stuff. And, I mean, if I can avoid y'all having homework this weekend, that would be great. So, starting out with the substitution problems, basically, the problem setup is going to look the same as what we had in the last section with the graphing, except for now we're solving them algebraically instead of graphically. So, number 4, we have 3x plus y equals 16 and 2x minus 3y equals -4. So the substitution method says we solve for one of the variables, so we get one of the variables by itself. So I'm going to always look for the thing that has either a variable that's already doesn't have a number in front of it or just has like a negative 1 in front of it, okay, to make my life easier. Because I could certainly solve for y down here, but why do that when I have a y by itself basically already up in the top? So I just need to move the 3x over. So I'm going to end up with y is equal to negative 3x plus 16. And now I take this and I plug it in for y in the other equation. So I'm going to have 2x minus 3 times negative 3x plus 16 is equal to -4. So I've got 2x plus 9x minus 48 equals -4. So then I'm basically now solving for x. So 11x is equal to 44. So x is equal to 4. So that's x. Now I need to go back and get y. So now I take this value that I got and I plug it in up here, okay, into the equation that I had converted. So I have y equals -3 times 4 plus 16. So y equals -12 plus 16. So y equals 4. What is happening out there? Now, a lot of times people stop here. You're not done yet, okay? Your answer needs to be written as an ordered pair for 4, okay? If you don't write it as an ordered pair, your answer is wrong. I will take points off. Now, if you're ever like, I don't know if I did that right, I don't know if my answer's right, you can plug this whole point back in and check it. So I will check it I'll just check it in the first original one just to show you. You're not required to check it, but I will tell you there is advantage to checking it because oftentimes people catch their mistake when they go back and plug it in. So we would have 3 times 4 plus 4 equals 16. So that's 12 plus 4 equals 16. So 16 equals 16. So we're good. Okay. So the checking for this would look just like it did for the graphically ones. As far as it was a little more critical you check it with the graphing ones because sometimes it's hard to see exactly where the intersection point is when you're graphing them by hand because there's obviously human error that comes with that. So not as critical here, but if you're concerned that you might have done something wrong, always a good idea to plug it back in. When we get to solving 3 equations with 3 unknowns, so it'll have x, y, and z that we're solving for, we will check those because those tend to have more issues with them. 8. 3x minus 4y equals negative 5, and negative x plus 3y equals negative 5. So, any idea which variable would probably be the smartest one to solve for? And in which equation? X in the bottom, okay, because all the other ones have a number in front. That one just has a negative, so a little easier to work with. So negative x is equal to negative 3y minus 5. Divide by the negative, so x is equal to 3y plus 5. So now, this 3y plus 5 is getting plugged in for x in the top equation. So I've got 3 times 3y plus 5 minus 4y equals negative 5. So 9y plus 15 minus 4y equals negative 5. So 5y equals negative 20. So y equals negative 4. So then now plug this in to this modified equation. So x is equal to 3 times negative 4 plus 5. So what is that, negative 12 plus 5, negative 7. And so then my final answer as an ordered pair is going to be negative 7, negative 4. Just ringing a bell. Have y'all seen this before? Emma has, but Christian hasn't. Maya, what did you say?
I probably did. I just don't remember.
I think I recognize it.
Where'd you take Algebra 1?
In your mom's class.
No, I'm talking to Christian. Not here, though, right?
No, your middle school.
Okay. It should have been in there, but was 8th grade y'all's COVID year?
No.
Seventh grade.
7th?
7th and 6th.
Yeah.
Like the year we went home, though?
6.
Okay. Because this is like at the end of the Algebra 1 book. That's why I was trying to figure out where. It's like chapter, well, I say that. It's like chapter 6 or 7. I guess it's not really the end, but. All right. Another one. So obviously these so far have just had one solution. Okay. So they've been consistent and independent. Okay. They've had one solution. It's not asking us to write that in this, but just as a refresher. But we still can have something come up to be infinitely many solutions or no solution. And so I think that was in the notes. But no solution is anything that gives you a false statement. So like negative 4 is equal to 7. Okay. Or 0 is equal to 8, something like that. That's a false statement. That's going to be no solution. And when you get that solution, like where it says 0 is equal to negative 8 or whatever, you have to write no solution to get the full credit for the problem. If it's infinitely many solutions, it's going to be a statement that's always true, like 4 equals 4 or 0 equals 0, something like that. And so that's when we write infinitely many solutions. Again, to have that be completely right, you need to have those words there. Okay, otherwise I'm going to think you don't really know what that means. So, number 10, 6x minus 3y equals 15, and negative 2x plus y equals negative 5. So which variable am I solving for?
Y on the bottom.
Okay, so y on the bottom. So y is equal to 2x minus 5. So I'm plugging this in up here. So 6x minus 3 times 2x minus 5 equals 15. So 6x minus 6x plus 15 equals 15. So the 6x's are going to cancel. So that leaves you a 0. Subtract 15. That gives you 0. So what is this?
I forgot the word.
It's always true, so it's...
What's the word? You just said. I forgot the word. It's like with I, right?
Yeah.
Isotonic?
Infinitely many solutions.
She said isotonic.
That is a different class.
What?
What is happening out in the hallway?
Brian, it was
Brian? What?
Now, the other thing is, if you didn't move the 15 over, you would have gotten 15 equals 15, and that still would be always true. So pretty much if your x's disappear, you're either going to have a false statement or an always true statement because, well, that's the only option. Otherwise, you don't have x equals something or y equals something. So, and that means that pretty much any ordered pair you plug in, if you plug it into both equations, it's going to work. So, but you don't really have to check those ones.
So, question.
Huh?
So that was the first I word that came to my head. I know, but I'm fine. I thought yesterday was Friday.
She made slime last class.
I thought yesterday was Friday, and then it wasn't Friday. So
I thought Tuesday was Monday, and I was really glad when I found out it wasn't Monday.
Yeah. So I thought yesterday was Friday, so I was like, okay, we get out, and then we don't get out. And I was like,
Yeah, I
oh,
told you Friday.
it's not Friday.
All right. Are y'all okay on substitution, or do we need to see another substitution?
We're good.
Good. All right. So now we're going to move on to elimination. Some call it combination. Anyways. So I sometimes use it interchangeably because when I learned it, it was called combination. And then I came back to teach, and all of a sudden the book started calling it elimination. And I was like, what? Anyways, so I've pretty much adapted to calling it elimination. But if you ever hear combination, that's why. So these ones are a little different. If I specify on a quiz or a test you have to use this method, then you have to use whatever method is stated. But there's also some problems in this section that say to solve using any algebraic method, so that just means you have to pick substitution or elimination to solve it. And so you can kind of pick your favorite. There's some that just make more sense to be done one way or the other. So we'll look at that too. But come on. Okay. Number 16. We've got 4x minus 2y equals negative 16 and negative 3x plus 4y equals 12. And so, again, with this method, we can still get infinitely many or no solution. Just the way that we get there is a little different now with elimination. So, elimination, I'm trying to eliminate a variable completely. Okay, and so what I'm looking for is a variable that I can multiply one equation by something and get it to cancel out that variable with the other equation. Sometimes you have to multiply both equations by something to get it to cancel. The way that a lot of books teach it is they will tell you to always multiply by a positive number and then subtract like the top from the, or the bottom from the top or whatever. I always say get it such that the variable will automatically cancel without you having to do anything. Okay, so basically, like in this case, I'm going to do the y's because 2 and 4, all I need to do is multiply this one by 2 and they cancel. Okay, this one is negative and this one is positive, so that'll cancel by just multiplying by 2. If they were both positive, I would multiply by a negative, whatever number it is. So I'm going to multiply this top equation by negative 2, or sorry, I'm saying negative, by positive 2. And so aside from having to rewrite it all again, I'm just going to rewrite this equation underneath here and then cross this one out that I'm done with it. So this is going to be 8x minus 4y equals negative 32. And what you've got to remember is when you multiply the equation by 2, it's multiplying all the way across, okay? Not just on the left side and not just the number that you're canceling. It's going through everything. So my y's cancel. So I have 5x is equal to negative 20. So then x is equal to negative 4. So I'm honestly a person that prefers elimination.
Okay.
Just because, I don't know, it's more satisfying to me. I feel like substitution is kind of all over the place, but I feel like I can be like organized with elimination.
So you're just using the cover up method?
No, not even close.
Wait, no. So what happened to y?
It canceled. 4y minus 4y is 0.
Oh.
You don't remember doing
That's why it's
that?
elimination.
I remember this like so well.
Like, get rid of it.
Okay, that's okay. Yeah.
Now, when you go to plug this back in, you can choose either equation, okay? Technically, when I rewrote this down here, I got rid of this equation. But what I'm going to tell you is if you choose to plug this in to the top equation, the original top equation, use the original. Don't use the modified. I mean, you can, but it makes your life easier if you use the unmodified one because you've multiplied it by something. So I'm going to plug it into, I'm just going to plug it into this one here, the second one. So negative 3 times negative 4 plus 4y equals 12. So that's 12 plus 4y equals 12. 4y equals 0, so y equals 0. And obviously, if you can do some of that in like the same step, you don't have to write out every single little step. Now, answers are still ordered pair, so negative 4, 0 is my solution, and we would check it the same way we've been checking. You just pick one of the equations, plug it back in, and check it. The other thing we could have done if we wanted to, I very rarely will do this because unless it all cancels somehow, the other option is instead of multiplying the top equation by 2, we could have multiplied the bottom equation by 1/2, and that would have given us negative 2y and positive 2y. But then I now have fractions over here because I would have had negative 3/2 x, which just gets to be annoying. So I very rarely will do that, but a lot of books do teach that as one of the methods, is you can multiply by a fraction. It's like, unless everything is going to be able to cancel out so that you don't end up with fractions, I wouldn't do that. And since most people hate fractions, I usually just avoid teaching that altogether. 18. 4x minus 3y equals 10, and 8x minus 6y equals 20. So things I look for when I'm determining what I'm multiplying by or which variable to pick, I'm going to look at, are there any variables that have numbers that one multiplied by something gives me the number of the other one? So like in the first one, we knew that if we multiplied the negative 2y by 2, that gave us a 4 for 4y. And then the other thing I'm looking for is, are any of them already opposite signs? So in this case, none of them, or neither of them are opposite signs, but both of them, by multiplying them by something, can get us to the number in the other one. So any ideas what we should multiply by and which one?
The top by. Oh, wait, you can't do that. I was going to say by -2, but you can do that.
That is what I need to do, -2,
Yeah, 5, 3y.
Then there'll be no things, right?
which I said we can have, right? I said we can have infinitely many or no solutions.
My brain doesn't work today.
So I'm going to just rewrite it underneath again to save another step of writing. So negative 8x plus 6y equals negative 20. So I got rid of that equation. So now combine this stuff. Everything on the left cancels. Everything on the right cancels. So I have what?
Infinitely many
Yeah.
Yep. Infinitely many solutions.
Okay, I think I got it now.
All right, I'm going to do one more and then we're going to stop for today. I'm going to give you 4 problems and then on Monday we'll finish the section. 22. 7x plus 2y equals 11 and negative 2x plus 3y equals 29. Also, the one thing I didn't mention is sometimes the problem will give it to you where something already will automatically cancel. Like they'll give you negative 2y and positive 2y, and you don't have to multiply by anything. It's rare at this point in your math career that they're going to do that, but it could happen. So with this one, are there any that have a number that I can visually immediately see that I can multiply by one of them to get to the other one?
No, you multiply by 2 for top by 3 and the bottom by 2.
Okay, so then my next thing is going to be, are there any of the equations that have opposite signs already?
So
yes.
x and 7x.
Okay, x already has opposite signs. However, this is what I'm going to say. If you were to multiply, now, some people will tell you find a, like, your, what is it? Greatest common factor? No. I can't think of the word at the moment. But anyways, where you, like, just keep going until you have a number that matches up and then it's, like, multiply by that. That's fine, but a lot of times that actually makes your math harder than just multiplying by the opposite number. So like the top one, if we were going to do x, I'm going to show you why I'm not going to do x though. I would multiply the top one by 2 and the bottom one by 7, okay? Because that automatically tells me they're going to cancel. And this one's not super obnoxious, so it's not a great example, but if I multiply the bottom one by 7, that means I have to multiply 29 by 7, and I don't know. That seems like a lot of thinking. Like, no, is it really hard? Not really, but there's an easier option, and I can just multiply by a negative on the y's. So I'm going to multiply the top one by 3 and the bottom one by negative 2. And it doesn't matter. You could do negative 3 and positive 2. It's not going to change it. And if you did x's instead of y's, you're going to get the same answer. So y'all may all three do it a different way and still get the same answer, because that could technically happen. So top one by 3, bottom one by negative 2. So 21x plus 6y equals 33. 4x minus 6y equals, not that this one's that much easier, but what is that, 1858? Negative 58? I think. Okay. 29 is just kind of a weird number. I don't know. Multiplying it by 7 would have been worse, though. All right, so then y's cancel, so I have 25x is equal to negative 25. Oh, that's nice. So x is equal to negative 1. Now, again, we've modified both equations. I would use the original, okay, just to save you from having to put it through basically harder math. So I don't care which one do y'all want to put it in, top or bottom. Emma, break the tie. Okay. All right, so 7 times negative 1 plus 2y equals 11. So negative 7 plus 2y equals 11. 2y equals 18. So y equals 9. So my solution is negative 1, 9. right, so we'll probably do a little bit of review on Monday. I'm going to go ahead and give you problems. They are not homework, though, if you don't finish right now, okay? Or if you decide that you want to wait and do them on Monday. I don't really care, to be honest. Basically, all we have left in this section is the problems that say to basically choose your method. So I'm just going to pick a couple and show you how I would go about choosing the method that I use. Most often, people find a method they like and they just do that method regardless. But there are some that you should definitely do one way or the other. Just make your life easier. So 3.3 notes will be due on Tuesday. So if you do these problems and you don't want to do anything over the weekend, there'll be time in class on Monday for you to do them, or should be. But anyways.